and welcome. We are getting ready to do the first of what will probably be, I'm going to think, 4 or 5 segments that have to do with the study of the water, of the quality of water. What you see in front of you here, this is called, let's see if I can get this where you can see it. Yep, there we go. This is called a backpack lab, and it comes to us from the Hanna Laboratories. The object of this exercise is that you can carry this out into the field and you can perform tests on the quality of water if you're studying the environment and the effect of pollution on water or the effect of runoff or fertilizer or whatever. I use this in the laboratory because this becomes equipped with several different experiments which we will be doing. So if I take this and I open it up, here we go. We have a Hardness Test Kit. We have, if I can get it out, a kit to test for phosphates in the water. We'll set that over on this side. We have an alkalinity test. Now, alkalinity has to do with how much acid can the water absorb before it starts to change and becomes toxic to plant and animal life. We also have an acidity test kit, basically the opposite of the alkalinity, more of a pH scale testing for our water if we need to do it. And we have my personal favorite, the dissolved oxygen test kit. Oxygen content in water, very important, because as we know, without oxygen, well, there's my carbon dioxide test kit. I was wondering where that went to. Oxygen and carbon dioxide. Without oxygen, fish and other organisms that live in the water would not be able to survive. So the rule of thumb is the higher the oxygen level in the water, the better the water quality. Conversely, the higher the carbon dioxide level, the worse the water quality. So there's that. And we also have our handy-dandy pH tester. And the final test that we will do is a nitrate test. Nitrates and phosphates are there are naturally occurring nitrates and phosphates, but we see this in runoff from agricultural applications, farms, feedlots, dairies, any place where human agriculture is interacting with the environment. And in the final thing, we've got some buffer solution to help clean our instruments when we're done. The final product in here, the final tool, is called a Sechi disc. Now, this one, and I'll open it up and show you what this disc is for. And we've not used this, but what this disc is for is you lower this disc into the water and you keep track of how deep you're going. You have a piece of rope here. You keep track of how deep this is. The deeper that you can go into the water and still see this disc, of course, the better the water quality. In the United States, you have 2 locations, Crater Lake in Oregon and Lake Tahoe in the Nevada and California border. Both of those lakes are used as the benchmarks for water quality, and these discs come in very handy. The deeper you can go, the better the water quality. And the one that's been concerning scientists for years is Lake Tahoe, because Lake Tahoe, as many of you know, only has one natural outlet, and that is the Truckee River. And there's been concerns that since the 1960s, the quality of the water in Lake Tahoe has been decreasing and getting worse, just simply because of all of the things that are being pumped into the atmosphere and intervention by man. I know that when I was in college, those of you that live in Oregon that might be watching this, I did have the chance to go to Lake Wallowa up in northeastern Oregon. And we were out on a boat, and I know the bottom had to have been 12 to 20 feet deep, and it looked like you were just 6 inches on top of it. So anyway, this is our water quality lab. I will be doing these experiments. I'm going to start with nitrates and phosphates, because these I can do together. We're going to be using a sample of water. Here's our water sample. Now, we've already done some tests on this using the sixth graders in the lab. This water sample comes to us from one of our students near Dexter, New Mexico. This comes from an irrigation well on their property. And here in southeastern New Mexico, back at the turn of the last century, the 1800s to the 1900s, when farming was first getting started, a lot of our water, we had very many naturally occurring springs and streams in our area. Farmers discovered that if you dug down about 100 feet or so, you would get into what was called an artesian layer. Artesian water is water that comes naturally out of the ground without any man-made assistance, without any pumping, no wells or anything. And for about 25 to 30 years, many farms in our area were irrigated with this artesian water. By the 1930s and 40s, because we had punched so many holes into the aquifer, the pressure had gone down. By the 1950s, very few artesian wells were left. And then by the 1970s, in our area, we were actually having to drill wells deeper to keep up with the water table because we were pumping it out so quickly. However, in the 1990s and early 2000s, instead of flood irrigation, farmers switched over to pivot irrigation systems. Those are the ones that do the circles. We have found in the last 15 years that the water levels are slowly recovering, and indeed, one of the teachers that I work with, her husband is a farmer in our area. They have a well that during the winter time, when it's not being used, the water does come up over the casing naturally and has resumed its artesian. It has become an artesian well again. So technology has helped us preserve the water. But anyway, this student would like to know the quality of this water coming out of the well. Most of our wells around here, again, a little over 100, between 100 and probably 250 feet deep to get into that artesian layer. Some wells are deeper, some are a little bit less. And so we're going to use this water, and we're going to do this. And this is the setup. And when we come back in the next segment, we will start with the phosphates and the nitrates.